Example 2, adding and subtracting rational numbers. Well, here's the thing. If we have two fractions that are divided into the same number of parts, in other words, they have the same denominator, you can just add the top bits, the numerators, like this. So suppose I have a fraction 3/4, so that's a whole, divided it into 4 pieces, and 3 of the pieces have something in them. And you've got another fraction that's divided into 4 equal pieces, and one of the pieces has something in it. If you want to rearrange this, well, these pieces are all the same size. So you can count up how many you have. Well, I've got 4 identical pieces. I add them together, and I've got three equal pieces from the first fraction, the 3/4, and I've got 1 equal piece from the second fraction, the 1/4. So now I have 4/4. So 3/4 plus 1/4 equals 4/4. Well, it's doing it in pictures, but doing it with numbers, here's how I do it. I got 3/4. That means I have 3 equal sized pieces, and then there's 1 blank piece left over. So what this means is I have 3/4 plus 1/4, where I have both of my fractions have the same denominator, meaning that in both cases a whole has been cut into 4 equal pieces. So now I got 3 pieces plus 1 piece equals 4/4. Anything divided by itself is 1, so that's just equal to 1. Well, what if I have 3/4 plus a half? So 3/4 plus a half. Well, there's a problem here because I have a whole cut into 4 equal pieces and a whole cut into 2 equal pieces. And the pieces aren't the same size. So if I color things in, I've got, well, the first whole is divided into 4 equal pieces, and 3 of the pieces have something in them. And the second fraction is divided into 2 equal pieces, and one of those pieces has something in it. Well, I can't add these fractions because the pieces aren't the same size. I solved this problem by what I need to do is to take my fraction, which is divided into 2 equal pieces, and rearrange things. So rather than dividing the whole into 2 equal pieces, it's divided into 4 equal pieces. Now, what I'm going to do, for my first fraction, I've got a whole divided into 4 equal pieces. So I'm going to color in 3 of them. And now, for the fraction that before was 1/2, I've taken one of those pieces, and I've actually divided into 2. So I'm actually going to color in 2 of the 4 equal pieces, because 2/4 is a half. Now my pieces are all the same size. The denominators are the same, and I can just count up how many equal pieces I have. Well, now, all these pieces are all the same size, so we can just count them. So I've got a total of 1, 2, 3, 4, 5 equal pieces. Well, there's 2 ways I can represent this. I could say that since I've divided both pieces up into quarters, I have a total of 5 quarters. Another way I could represent this is saying I've got 1 whole unit, so 1 whole unit, and then with the second unit, only one of the 4 possible boxes has something in it, so it's a 1/4 filled, so that's the same as 1 and 1/4. doing this with numbers, what I would have is 3/4 plus a half. I have to recognize that I need a common denominator here on this fraction. So what I'm going to do is I say that this is the same as 3/4 plus 2/4. Well, okay. So now I've got the same size denominator, so this is equal to 5/4. What if I have a fraction like this? 3/5 plus 2/7. Well, here we go. So that's 3/5. I'm going to give a big fraction bar plus 2/7. Well, what I've got to do is I've got to find a common denominator. You can always find a common denominator, and this is a trick that works with fractions, also works with algebra. I'm going to take the other denominator and multiply it by its mate. So I'm going to say, okay, well, I'm going to multiply the 5 by 7 and the 7 by 5. But I can't just do that arbitrarily to a fraction. Just change something like that in the denominator. Whatever I do to the bottom, I got to do to the top. So I'm going to do that top up there. Okay, so that makes 7/7. Well, anything divided by itself is 1. So I haven't actually changed anything. It's just kind of like a party trick. I'm just modifying the fraction so that it will have a common denominator. I can do the same thing to the other side. Well, I got 2/7, and then I multiply the 7 times 5 in the bottom. I can't just do that. I can't just multiply the bottom by 5. I need to also multiply the top by 5. And once again, I got 5/5, which is a 1. I haven't actually changed anything. I'm just scaling the fraction. And basically chopping it up so that I've got the same size pieces that each fraction is divided into. So now, well, what does this turn out to be? So this turns out to be 21/35 plus 10/35. Well, now I have the same denominator with this fraction, so I've got what's called a common denominator. I can write my numerators down, 21 plus 10, and I can use one big fraction bar and write over the one denominator, 35. Now I can add the numerators, and this becomes 31/35. Turns out 31 is a prime number. This doesn't reduce anymore. Here's the thing. You all have calculators in your courses, and your calculators either are graphing calculators with a fraction button under the math key, or they're a scientific calculator with an ABC key. ABC keys do fractions. Make sure you ask your instructor how to use the ABC key to reduce fractions. And your calculator will reduce a fraction to lowest terms for you, if it's at all possible. Now subtraction is really the same as addition. The concept is you have to have, well, the concept really is the same. The concept is you have to have the same size pieces that your fractions are divided into, so that you can either add pieces together to find out what the result is when you add two fractions, or you could subtract pieces from each other that are the same size if you're doing a subtraction. The key is the pieces have to be the same size. Well, if the denominators are the same, the pieces are the same size. So let's just take a look at this fraction. That's like 5/8 minus 1/8. Well, the pieces are the same size. Here, let's just do it pictorially. So I've got a fraction here representing 5/8. I've got a whole divided into 8 pieces. I'm going to take one of these pieces away, like this. Well, look at that. Subtracting fractions uses a concept that's also used in adding fractions. And the concept is you have to have the same denominator to do a subtraction, which means that for each of the fractions that you're working with, they have to represent a whole that's divided into equal parts. Well, let's suppose I've got 5/8 minus 1/8. I'm going to represent 5/8 by taking a whole and dividing into 8 equal pieces, and then coloring in 5 of the boxes. Now, these boxes are all the same size. I'm going to take one of them away, like this. And now I have 4/8. Just 4 boxes are colored. Using numbers, I would have 5 minus 1 over the common denominator, 8. 5 take away 1 is 4. Now you have 4/8. Well, 4/8 can be reduced because 4/8 is the same as 1 times 4 divided by 2 times 4. The greatest common multiple here is 4. Anything divided by itself is 1. So 4/8 reduces to 1/2. Okay, so now I've got two other fractions. 7/8 take away 2/3. Well, I gotta have the same denominators in order for me to subtract. So what I need to do is make that happen. Well, I'm going to use the same strategy for finding a common denominator that I used in addition. Here we go. 7/8, that's 7, big fraction bar, over 8, minus 2, big fraction bar, over 3. Now I've got to find a multiplier. Well, with the first fraction, I've got an 8 in the denominator. The other fraction has a 3, so I'm going to multiply 8 times 3. If I do that to the bottom, I do it to the top. With the other fraction, it's got a 3 in the denominator. The other fraction has an 8 in this denominator, so I'm going to multiply the 3 by 8. I'm going to multiply the 2 by 8. What I end up with here is 7 times 3 is 21 over 24 minus 16 over 24. Now I have a common denominator. Both fractions have been chopped up into the same size pieces. Each whole has been chopped up into 24 pieces, and they're all the same size. The first fraction has 21 things and 24 of the pieces. And then we're taking 16 of those away. So what we end up with is 21 take away 16 over 24, which is 5 over 24. Well, here we have a mixed number, 3 1/3. Here's how you deal with this. You take the denominator, which is a 3, multiply it by the whole number, and add the numerator. So I'm going to go 3 times 3 plus 1. 3 times 3 is 9, plus 1, 10. So 3 1/3, I end up with a 10 for a numerator, and it was divided into, each whole was divided into 3, so it's over 3. There's 10/3. So once again, I took the denominator of the mixed number, multiplied it by the whole number portion of the mixed number, so 3 times 3, and added the numerator. That allows me to write the mixed number 3 1/3 as the improper fraction 10/3. Now I'm taking away 2/3. Oh, look at that. Both fractions have the same size pieces. So I can have a common denominator right away. So 10 minus 2 over 3. Oh, okay. Well, that's 8/3. You can just leave that as 8/3. I'm happy with that as an answer. Your calculator will convert 8/3 to a mixed number. Ask your instructor if you're unsure how to do that. Using long division, what you would have is 8/3. Well, 3 is the divisor, so that becomes 3 into 8. 3 goes into 8 2 times. 2 times 3 is 6. Subtract 6 from 8. You have a 2 remainder. So this means that 8/3 equals 2 and 2/3. The remainder becomes a numerator, and your divisor is, well, how many pieces the whole is divided into. All right, now I'm going to subtract the mixed number. I'm going to subtract 3/5 from the mixed number 1 and 2/7. Here we go. First thing I'm going to do is I'm going to convert the mixed number 1 and 2/7 to an improper fraction. 1 times 7 is 7 plus 2 is 9. So it becomes 9/7 minus 3/5. I've got to get a common denominator. What I'm going to do is I'm going to take the first fraction, 9/7. I'm going to examine the denominator. That's a 7. The other fraction has a 5. So I am going to multiply the 7 in the fraction 9/7 by 5. So I've multiplied the denominator by 5. I've got to do the same thing to the top. So don't change the fraction. 5 over 5 is 1. So I haven't really changed anything. I'm just scaling the fraction up. So it's divided into the same number of equal pieces as the other fraction. Now, the second fraction, 3/5, I'm going to take the 5 multiplied by 7. I'm going to do the same thing to the numerator. So now I haven't actually changed the value of either fraction. I've just done a slight modification. Well, what is this result? This means I've got 9 times 5 is 45 divided by 35 minus 3 times 7 is 21 divided by 35. Well, I've got a common denominator, so this becomes 45 minus 21 over 35, which is equal to 24 over 35. Now, 24 over 35 doesn't have a common factor in both the top and the bottom, other than 1, which you can't really do anything with. So that's it. 24/35 is as low as it goes. Well, multiplying fractions, it's important that you notice the difference between adding and subtracting fractions and how we're going to find out how to multiply and divide fractions. Adding and subtraction fractions, you must have a common denominator. Multiplying fractions is dead easy. All you do is you just multiply the numerators together, multiply the denominators together, and then reduce the fraction. Just like that. So you're going to go, okay, 2/7. That's 2 times 3 over 7 times 5. 2 times 3 is 6. That's 35. That's in lowest terms because there's no common factor other than 1 in both the numerator and the denominator. So you're done, 6/35. Okay, what about this next fraction? It's a mixed number. Let's take a look at that. Okay, once again, 2 times 5 is 10. Add 2 to make 12. So the first fraction becomes 12/5. Okay, and then this is times 1 and 1/3. Well, 1 times 3 is 3, plus 1 is 4. So that becomes 4/3. Okay, so I can put this over one big happy fraction bar. So I've got 12 times 4 or 5 times 3. Oh, okay. Well, I can just multiply this out, and I'm going to show you a trick. First of all, let me multiply it out. 12 times 4 is 48. 3 times 5 is 15. And then what I would need to do is I would need to recognize that both 48 and 15 have a common factor, 3. So this actually becomes right at this stage where you've determined that you're going to be multiplying the numerators and denominators together, if you see that 12 is the same as 4 times 3, that what you can do is you can have a cancellation occurring here. Well, cancellation, let's just say it's a cancellation. Really what you're doing is you're dividing 3 by itself, and that's equal to 1. So 1 times anything is the thing itself. It's the property of 1. So what I'm saying here is you got 12, and 12 breaks down into 4 times 3. Well, if you do that, if you see that you can factor 12 into 4 times 3, then in your calculation you got a 3 in the numerator, a 3 in the denominator. Anything divided by itself is 1. So what you're left with is 4 times 4 in the numerator, which is 16, over 5 in the denominator. So I think it's probably easier to see that 12 factors into 3 times 4 than it is to see that 48 factors into 3 times 16. So the message is, if you see something that factors easily, see what sort of cancellations you can figure out from that. Okay, dividing fractions. What we're going to do is any problem involving the division of fractions, we're going to convert that into a multiplication problem. We're going to transform it. And the way you transform a division problem into a multiplication problem is, well, just what's written here. You leave the first fraction alone. Then you take the second fraction, like that's this one here, say, one in my question, the 1/4, and swap the numerator with the denominator, and then multiply the resulting fractions. So what I'm going to do is I'm going to rewrite this. This becomes 3/4 times 4/1. When I'm multiplying, I'm going to have one big fraction bar, and up top I've got 3 times 4 in the numerator, and I've got 4 times 1 in the denominator. So what I have up top, I've got a 4 in the numerator, and I got 4 in the denominator. Anything divided by itself is 1, so the 4's cancel out. So what I'm left with is a 3 up top and the 1 in the bottom. A rational number, which if you recall, can be written as 3. Now, the next fraction problem, what do we have here? We've got 2/5 divided by 3/10. Well, what I'm going to do is I'm going to take the 3/10 and swap the top and the bottom. It's going to become a multiplication problem. 10/3. So I'm going to take my multiplication problem and put it over one big fraction bar. I have 2 times 10 up top, divided by 5 times 3 in the bottom. But if you recall, with the last question, I said, well, if you see something that can factor easily because it's a smallish number, well, let's factor it and see if there's any cancellation that can occur. Well, what happens here? Well, you've got 2 times 10. Well, 10 is the same as 2 times 5. So I'm going to have 2 times 2 times divided by 5 times 3. Well, now I've got 5 up top and 5 in the bottom. Anything divided by itself is 1. So what I'm left with is 2 times 2 is 4 over 3, 4/3.